and share my screen. So I have made this PowerPoint that I'm going to embed on Canvas. Actually, I already embedded it. I'll show you what I'm talking about in a second, so that you can access it at any point in time in the future and use it as notes, as a way to study. Also, there's an extra credit opportunity that's included at the end of this virtual session. So we will get started here. So today's session is about waves. Again, I know we talked about waves in the last one, and also previewing the circuit vocabulary in the electricity module, module 3, which is where most people are about to be or starting. So we will review our waves vocabulary. We're going to look at a mathematical relationship between frequency and wavelength. We're going to review the double slit experiment, which is for tomorrow's lab. And we're going to preview circuit vocabulary, and we're going to talk about an extra credit opportunity. Sounds like a lot, but I promise this is only going to be about 30, maybe 40 minutes, depending. I'm not going to talk too much. Okay, so waves, right? These are the 4 main bullet points that I made for waves. Just as a summary, again, you can write this down as we're going here. You can always access this. Excuse me. So, oh no. All right, I have to calm my throat down with coffee. Okay, much better. Okay, so all waves are a movement of energy, right? They're some kind of movement of energy. Some waves, like sound waves, require a medium to travel, right? So that's one of the biggest distinctions, is that like sound waves, water waves, obviously they're in water, require a medium. And electromagnetic waves don't, right? They can travel through vacuums. Electromagnetic waves also contain an electric and magnetic field, right? They travel at the speed of light, even if they're not light. And they're both a particle and a wave. So electromagnetic waves are way more complicated than a regular sound wave, for example. So what we're going to do in the lab tomorrow is, if you're not there in person, I am going to provide an online virtual lab to do, just because I don't think I'm going to be able to capture what we're doing on the computer. I might try, but basically we're going to make, first of all, we're going to use tuning forks that produce sound waves, and we're going to look at what happens when you put them in water and air, right? And we're going to just observe waves happening and review a little bit about what a wave looks like, labeling the parts, etc. And then we're going to make a double slit out of aluminum foil. And I got a laser pointer, so we're going to point the laser through, and then we should be able to prove that light is also a wave. So that won't be as cool looking on the computer if you're like watching from home, because you'll just see us being like, whoa, cool, and not really know what's going on. So I'm going to provide you with an alternative that gets the same concepts across, but that you would just do from home. And then the last thing about waves here is that waves have a frequency, right, which is best described as cycles per second. How many times is the wave itself cycling? So mathematical relationships. I'm actually surprised and sad that they did not include this in the curriculum. I'm obviously going to put it in for next year, but this is a super important mathematical relationship, and it's not hard, right? Some physics math gets like crazy complicated, but this is a really simple formula where we end up getting that the wavelength is equal to the speed or the velocity divided by the frequency, right? So from this formula, we can tell that there is a relationship between frequency and wavelength, right? There is a relationship between the speed of the wave and the wavelength and the frequency. So we could do really complicated math with this, but we're not. I'm going to show you guys a simple equation here. And I tried to include the formula up there. Okay. So these are the kinds of problems that you could see. which, by the way, I might be teaching physics next year, so maybe you guys will want to take physics, and we'll do more of this. If the frequency of a wave is 500 hertz and the velocity is 366 meters per second, what is the wavelength of this wave? Right, so you start by writing the formula. Frequency is equal to velocity divided by wavelength. Right, got that from right here. You can also write it wavelength is equal to velocity divided by frequency. We won't prove, but it's the same thing. So all I did was just plug in the numbers that I know. I didn't put my meters per second unit because it got a little messy looking. But 500 hertz is equal to, oh, that's loud. I gotta mute you, sorry. There you go. Oh, nope, did I? Yep, okay. Oops, no, I wasn't ready, slide. Okay, oops. It's not gonna let me go back now. There we go. So I just plugged in the numbers that I know, right? 500 is equal to 366 divided by the wavelength. And I did a little bit of math here. I multiplied by the wavelength so that I ended up having 366 divided by 500, right? And I got 0.732 meters as my wavelength, right? That's pretty, that might sound small to you, right? But if you think about how big a meter is, and we think about a wavelength being the crest of the wave to the crest of the next wave, right? A meter is pretty long for a wavelength. And some waves do get that big, right? But for the most part, waves are smaller. I have to keep checking on my dog because for some reason when I do virtual sessions, he likes to chew on things. But he's chewing on his toy, so it's okay. So that's just a really quick little math example here, right? Using this formula. So now you guys are gonna try. We're gonna use this awesome thing called Poll Everywhere, where you go to this website here, you can click on it, pollev.com/JamieDinsMoo438. Not sure why it's not just my whole name. I guess it was one letter too long. Or you can text from your phone. And I'm gonna move this thing out of the way here. So you guys are gonna be solving this question, right? If the wavelength of a wave is 0.44 meters and the velocity of the wave is 5,000 meters per second, what is the frequency? And it was supposed to show my little formula guy. So we'll go back for a second here just so people can see the formula. So take a second to quickly write down the formula. That the frequency is equal to velocity divided by wavelength. Just because it's not going to show up on the next slide. All right, so I'm going to give you guys a couple of minutes here, right? In fact, I can write the formula on this. I can get it to annotate. I'm going to give you guys a couple of moments here to solve this question. Actually, oops, if I could spell wavelength correctly, that would be helpful. Okay, so there's the formula. Frequency is equal to velocity divided by wavelength. And here's your question. Oops, I blocked the question, didn't I? Oh, difficulties. Okay, hold on. Okay, now we're gonna be in business. Yes, okay. Formula is there, question is there, answer choices are there. Take a second to solve this and then go to this website and click whether you're picking A, B, C, or D. So I'm gonna give you guys a couple of minutes here to do that. I should have put the Jeopardy music, right? Da, 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 da. No. All right. We have 100% of people saying A so far, but how many people have answered is the question. I can find out. 3 people have answered so far. Okay. We'll wait just a tiny bit longer. If you guys couldn't tell, by the way, I'm obsessed with this poll everywhere stuff. It's fun. Well, at least I think it's fun. It's better than just you sitting there doing nothing. And guys, remember, I have pretty much everyone muted. If you need help or you're like, what are we doing? Why are we sitting in silence? Just go in the chat. If you go to the top of your screen, a little bar will come down and you can click more and you can click chat, right? And then you can say something to me if you're confused. And I try to look at it pretty frequently. Okay, so at this point, we will quickly show how we solved this. So, all right, so we have our formula. Oh, we got a couple more answers here. Right when I was gonna write in the center of the, the white space. All right, we had our formula, frequency equals velocity divided by wavelength. So what did we do? We're looking for the frequency. So we don't know what that is. The velocity, the question told us the velocity was 5,000 meters per second. We're going to be dividing that by the wavelength, which the question told us was 0.44 meters. Right? So to get our answer, we're just going to very simply take 5,000 and divide it by 0.44, which actually will give us choice A here, 11,363.6. And since I made this question, all the other answers are derivatives of this in terms that, uh-oh, I hear somebody is not muted anymore. So, I don't know, let's see. Get out of here, annotation. All right. Who's not muted? Possibly Karen. Okay. Well, let's go down. So our answer was 11,363.6. And then
what?
Put the unit there. It should be hertz for the units. Right, so basically for these kinds of problems, which you're really not going to see too much in this course, I just want you to understand there is a relationship between the wavelength, the velocity, and the frequency, right? There is this mathematical relationship, and that is how, when you study waves in more detail, you would get to do that. Okay, so moving on here, let me erase my annotations. Okay, so we'll just go to the next slide here. So the next topic here is the difference between particles and waves, right? Which last virtual session, I kind of started talking about this, and then I realized it was going to be too much complicated stuff to tack on to the end when I wasn't planning on talking about it. So I planned it better this time, right? This is really just 2 main categories that things get put into, right? Is it a particle? Is it a wave? That's pretty much what physicists were using to classify stuff. So particles have a mass, they have a charge, they have a location, right? And they usually move in linear patterns. Think about a ball, right? A ball is like a huge particle. If you have a ball, it has mass, it has charge, it's neutral, right? It's not charged. Its location, maybe it's in your hand. And then if you throw it, right, it pretty much goes straight. Might curve a little bit, but it's not going to do any crazy like thing where it splits and goes in 8 directions or something, right? It's pretty predictable. If you throw a ball, it's going to go where you tried to throw it. Waves are a little bit different, right? Because they're a movement of energy. They can travel around barriers. So think about if you're hiding from someone, right? Even if you're hiding in a closet, you can still hear sound, right? You can hear them walking, you can hear them maybe saying your name, whatever they're doing. You can hear the sound. So even though there's a wall or a door there, the sound is able to travel around that wall. It really travels through the wall to some extent, right? So that's a little bit different than a ball. If you threw a ball at a wall, it would hit the wall and stop. It's not going to go through the wall or around the wall. But waves do that. They do that on their own. You don't tell them to do that. They just do it. So why should we care? I took this really long quote. I'm going to read to you guys some super nerdy physics stuff here. All right. Ordinary everyday experience shows that waves behave very differently from particles. For example, if you are taking cover behind a wall from a person shooting peas at you, you will not be hit. Yet when she screams that you are a chicken, you hear her perfectly well. Sound waves, and all waves in general, have the ability to go around obstacles. See, I was just saying this. Up to a certain extent. The wall is very tall and wide, the insults will not reach you. Particles have no such ability. The above properties of sound waves are well known, but if light is a wave, should it not behave in the same way? And if it does, how come we do not see a person standing behind a wall whom we can hear clearly? Right? And then this person, this is like the intro to their book. They're like, now I'll consider this paradox. And then they talk about light and waves and all this other stuff. Right? So the concept here is light behaves kind of weird, which it's true. If somebody's standing behind a wall, you can't see them, right? But is the light getting in there? We shall find out. So does light behave the same as sound? Right? Yes and no. Is light a particle and a wave? This was like the biggest science question of the 1800s. So pretend that it's 1805 and this is the one thing that you care about learning about. Right? We did know that light contains photons, which are tiny particles. So if you look at a stream of light, it's actually made up of tiny little particles. Right? Those are the particle aspect of light that allows it to sort of do a direct beam, right? Like you can shine a laser of light at somebody. Light can also bend around corners and it can travel like sound, right? So you may have observed this if you ever have a light on in one room and your door's open, the light kind of creeps out of the door a little bit. You can see it kind of going out. If it was a particle, it wouldn't do that. So this guy, Thomas Young, does this experiment called the double slit experiment, which we watched a video about last time. And I'll show you where those are linked. But basically, he showed that light is also a wave. Before, scientists only thought it was a particle, right? Because it's made up of particles. So they thought, well, obviously it's a particle. And then this guy's like, nope, actually it's a wave. And then everyone sort of argued about it for probably 100 years. And then they decided, you know what, it's both. Light's both. It's a particle and it's a wave. It's special. Right? This led to the development of quantum mechanics, which is like the super intense physics where you study molecules, right? And this is where you get into all those weird theories where you don't actually know where something is because when you're looking at it, it's in a different place than it was when you looked at it. There's a lot of like really like philosophical parts to this type of physics. So this actually led to like the study of electrons and studying particles and how they move. So this is what we expect to see in a wave versus a particle. This says wave behavior, by the way. Okay, so if we have our double slit experiment, which is basically where we have a light source, we have a wall or some kind of barrier that has two slits cut through it, right? So just two little areas for things to pass through. For a wave, right, when a wave passes through, the waves actually start to create these interference patterns. You may have even experienced this with sound waves, right? Sometimes sound waves interfere with each other and you don't hear anything. It's really strange. And we end up getting this pattern on the wall where there's a really dark band in the center because there's tons of the wave hitting there. And then there's these bands going out to the side, right, where waves are also hitting. And then there's these dark empty spots, which are the interference parts where the waves are actually canceling each other out. A particle, right, if we take something that's a solid particle and we push it through these slits, we get the same thing that well, not the same thing. We get something we would expect here. We get two lines of particles, right? They just went on top of each other. We don't see other bands, right? We don't see anything like that. So we're gonna actually do this experiment tomorrow with light using a laser beam, and we're gonna see what we see. Do we see just two lines or do we see this interference pattern? All right, so that's my spiel about light. I'm done talking about it for now. Like I said, tomorrow, the virtual session, it's not really gonna be a session, it's gonna be a Google Doc with instructions for you to complete the lab at home. And if you are in the school doing the lab with me, then we will do the lab together. So try to come in to Miwa if you can, because it's gonna be more hands-on experience than doing it at home. If you can't, don't worry, I will send you videos and stuff to watch. All right, so the next thing I wanted to talk about is vocabulary, right? So circuits and electricity is the third module. There's a lot of vocab there. Some new vocab that maybe you've never heard. So I found these two great Quizlets that are already created. If you've never used Quizlet, you are missing out. So basically Quizlet is, as it sounds, it is a quiz generating kind of software thing. What is this? Not software, website. Why can't I move this? There we go. Okay, so science vocabulary words, electricity, right? They have different topics. So this person went through and wrote all these words and all these definitions, right? And these are all things that have to do with electricity and that you will be learning. So you can study these by doing flashcards. So if you do the flashcards, right, it will give you the card and you click to flip. So that's an electric current, the flow of electricity through a conductor, electric current. You can keep flipping back and forth, right? Then when you're ready, you go to your next card, do the same thing, right? So it's a helpful way to study vocab. You can also make your own Quizlet where, okay, who's making noise here? Let me see. Okay, so you can also make your own Quizlet and make your own flashcards, right? I highly recommend this for when you take the segment exam because you're gonna have to remember vocabulary from all three modules, right? And some of it you don't really use very often, so you might forget it. So I linked in this presentation 2 different Quizlets that are pretty good for vocab on this module. Also helpful, there's a video here, it's actually a TED Talk about how a battery works. Right, batteries are a big part of electricity, right? And they're also a big part of our lives because most of the stuff that we use all the time is powered by batteries. So it's important to understand how they work, right? Especially so that we can make them better because batteries do have some limitations. As you know, when your phone dies after 3 seconds. Oh, so annoying. Okay, so, okay. So I'm gonna show you guys where I posted this so you can see where you can access the links. But I recommend that you preview this vocabulary before you start the unit. Look at it. What are you gonna be learning about? You're gonna be learning about currents, you're gonna be learning about batteries, you're gonna be learning about anodes, cathodes, resistors, insulators, right? And kind of getting an idea of what you're going to be doing. Last thing. Oh, whoa, it just went into full screen. That was pretty cool. Is an extra credit opportunity / something that's kind of fun. So I found this cool circuits website where you can actually build your own circuit, right? So you can do this extra credit at any time until the end of the semester. So if you're not quite on to circuits yet, perfectly fine, right? You can wait like 3 weeks and then do this. It's going to be there on the modules. So basically you go to this website and you click Try Circuit Simulator, and it's completely free, and it loads here. And it actually gives you instructions on how to build the circuit, right? So that you don't really make mistakes. And it's pretty cool because circuits are kind of hard to understand until you actually can play with them. And this is, yes, it will help your grade for sure. This is a good way to virtually create a circuit, right? So it tells you step 1 here is to add a source. And so if you look over here, you can see there's different sources. And you just drag and drop it onto your board here. And then it'll tell you to add components, right? So you can add a wire. You can make the wire like have whatever kind of shape you want, right? You can always go back and add more wire. Okay, so there we go. Simply here we have a battery and we have a wire. Nothing crazy going on. We can start adding resistors here. We can add insulators.
Look what I got yesterday.
We can add a grounding option, right? So there's all these things you can add, and it'll kind of give you advice and help over here on the right. And then you can run your circuit. So I don't think I can run it yet because I didn't add a measuring device, right? So you have to complete it before you can run it. But you can actually see it work. And it'll give you sort of suggestions on how to make your circuit better. So to get the extra credit, build a circuit, and you're either going to take a screenshot, which if you don't know how to do, I included a link, or you're going to screencast your circuit working, where you actually like record your screen, kind of like what I'm doing right now, but you would show either yourself building the circuit or the circuit running. And that will be to get the extra credit. So I hate how this menu thing comes down. Okay. So how do you record yourself? Yeah, so I actually included this website here. It's called Screencast-O-Matic, and it's really easy to use. If you have a Mac computer, you can also use QuickTime to record your screen, which is pretty easy. You can also Google specifically for whatever kind of computer you have. So I don't know if Screencast-O-Matic will work for a Chromebook, but there's definitely a way to do it on a Chromebook, right? So I didn't want to include like 40 links here, but you can easily just Google how to screencast on a Chromebook, and then you'll get an option, right? There's probably like a Chrome extension, I'm guessing. But if you have a Windows or a Mac computer, you can use this website, Screencast-O-Matic, where basically you just push start recording and it will just record your screen for you. It's pretty cool. It's actually useful, especially for online school, because then you can show your teacher like what you're doing, right? Or you can do a presentation, you can record your voice even. So I could have recorded me giving this talk on top of the PowerPoint, and you wouldn't see me, you would just hear me talking about everything. So it's a good way to present, right? If you ever have to do a presentation, it's a nice way to present without having to like stand in front of people or show your face, because you can just use your voice. Where do you find the Quizlet sets? Great question. So this is what I've done. Actually, I want to show you two things. So in Canvas, first of all, I don't know if you guys have noticed this, but you could pick any lesson, right? I just picked circuits. There's a glossary. Now, it's not awesomely specific to that lesson. It's not just the words from there, but it actually shows every vocab word that we're going to learn this entire year, right? So it includes words we've already learned, and then it includes things that we'll be doing next semester, which are more chemistry-oriented things. So you can go through here, right? You could even print this out and have it in your notebook and highlight the words as we go through them. And then there's a nice, none of these definitions are super crazy long, right? They're pretty easy to understand. So this is a really great source that I don't know if people have seen. You know, it is kind of annoying because it's all the words, but again, you could highlight, you could break it up. It gives you an idea too of what we're going to be studying next semester. So, all right, otherwise, to find the presentation from today, right, to find the Quizlet, to find the extra credit stuff, you're going to go to modules, and yeah, so the thing is, I don't think we have a full end of the year exam. I think it's just segment 1 and segment 2. So segment 1, you'll have an exam on everything that we learned from now, or from September to January, right? So Newton's laws will be there, all the force stuff, all that will be on one test, and electricity and all of that. It's an online test. It's just like the ones that you've been taking. There will be some short answer, some multiple choice. Then second semester, same kind of thing. At the end of the semester, you'll have a test that's on everything in second semester, right? So the module exams that you've been doing so far probably haven't been too hard just because they haven't had a lot of content, right? It's been one module. But at the end, coming up in a few weeks here, you will be tested on the entire semester, right? So that can get more complicated. Okay. So yeah, so like module exams. So at the end here, why isn't this loading? Oh, there we go. All right. So see segment 1 exam. That's what I'm talking about, where they're going to have vocabulary from every module in this entire semester. But this is what I posted here. It's called Physical Science Virtual Session on 12/12. If you click on that, it's the first thing in module 3. You will see this PowerPoint is embedded here, right? And you can go through the slides. You can see what we did if you missed part of it. And then here are the links that you can click on and the extra credit that you can click on as well. And then I'm going to upload the video that I'm recording right now of this happening. And then I'm also going to be making a page for the lab tomorrow. Like I said, if you're doing it from home, it's going to be slightly different. You're going to be watching the video and doing something sort of independently at home, just because I don't think it's going to work with the computer. So that's pretty much it. If you guys have questions, feel free to put them in the chat. Otherwise, this is pretty much the end of this session. I think maybe we should look at the calendar. I don't remember how many more of these we have. The at-home lab tomorrow, it'll be posted probably tomorrow morning. You can do it at any time. It's just going to be due by Friday. If you come in person to me while the lab tomorrow is at noon, and it'll probably take about 45 minutes. So if you're coming in person, it's at noon. If you're doing it from home, it's going to be due by Friday. There's not going to be an exit slip, actually. What I'm going to do is if you guys could just type your name in the chat so I know that you're here and that you're listening to me right now and hear what I'm saying. Okay, so actually, yeah, okay, thank you, Abby. Abby's modeling right now exactly what I'm talking about. Abby, Alana, Andrew, Alina, Elizabeth. Ooh, both Elizabeths. All right. So what I'm going to do is Karen. Oh, you're under your sister's name. That's fine. Yeah, sometimes, yeah, you might have been on her account. It's fine. As long as it's not like Poopy Pants 3, because I had middle school kids logging in with like weird names. As long as it's a name, I'm happy. Okay, so I have Abby, Milana, Andrew, Alina, both Elizabeths, and Kieran. Okay, so yeah, you guys aren't going to have to do an exit. I figure if you come to the virtual session, that's it, that counts. So I'm going to keep track of that. People who have to watch from home are going to have an exit. So they're going to have to do something else. but you guys don't have to. So again, tomorrow is at noon will be the lab in person. And if you're doing the lab from home, it's going to be due by Friday. And oh yeah, I wanted to check out the calendar really quick just to see how many more of these things we have. What will you be doing at home? You're going to be doing things with waves. So I'm going to send you some videos and you're going to be answering some questions about the double slit experiment and about waves and how they work. So it's pretty simple. It should probably take you about 30 minutes to do at home. How do we turn in the lab or the virtual session? Both. So the lab you're going to be emailing to me because Canvas doesn't let me add new assignments, which is a fun twist of life. So you're going to be emailing the lab to me. There will be instructions on the Google Doc that I sent. For the virtual session, you don't need to do anything. It shouldn't even show up on your Canvas calendar because I didn't make an assignment for it. So it should be fine. You don't need to turn anything in. I have everyone's name written down here. Otherwise, let's just see when the next events are. Okay, so tomorrow we have the lab, right? By Friday, it will be due for people working from home. Then we have 2 weeks off. And then, let's see, let me go to January here. So in January, we have one more virtual session, one more lab, and we have an optional lab time where you can come in and work with me if you want to. So this last required lab is like basically right before the semester ends. We're going to be building circuits, which I'm pretty excited about. I ordered circuit kits, so you're going to build your own circuit to light up a light bulb. Pretty cool stuff. Hey, Kendrick. Otherwise, hey, stop. Otherwise, we just have one virtual session left. Kendrick, come here. And we have one more lab after the one tomorrow. We'll just pretend that that one already happened. Is this class mostly taken by middle schoolers? Nope. This is all high schoolers. It's 9th graders. I think there might be a few 8th graders in the class, but it's like 99% 9th graders. All right. So that, I think there's like a male person near. My dog can sense FedEx delivery people from half a mile away. Okay, so that's pretty much it. I'm going to end the session here. Always feel free to email me or text me if you have other questions or you think of a question after this ends. All right, so thank you for everyone who is able to come. And I will see some of you guys tomorrow, and I will be sending out instructions for what to do if you're doing the lab from home. Okay, bye everyone.